Hi class! Today we are going to talk about stacks. It is chapter 20 of your textbook, stacks and queues. So stack, a collection based on the principle of adding elements and retrieving them in the opposite order. It's known as last in, first out data structure. The elements are stored in order of insertion, but we do not think of them as having indexes. So we don't care about indexes, okay? You can only add, remove, examine the last element added, which we call the top. And here you can see stack of trays. So here's the top right here, and it has bottom. So you cannot access any element but top. To be able to access any other element, you need to first to remove top, right? Top and then remove top again and again until you somewhere wherever what you want to access. So stack has three main operations, which is push, means add an element to the top. So to add, we call it push. Pop, remove the top element. So to remove the top, we call it pop. And pick, just to look what element it is or examine the top element. This method would return value of the top. And here you can see stack. It has bottom, top. It has three elements, which is element 1, 2, and 3. And again, what you can do with the stack, you can add one more element, or not just one, you can add several elements. But if you want to remove something, it's going to be always top element. So you cannot access anything else but top element. And you can see it here, right? What else you can do? You can pick on top element, right? And you can remove it, of course. Let's take a look at a couple of examples. Here we can see stack of coins, stack of trays, stack of boxes, and stack of books. So again, you can access only top element. And that's it. Let's see some examples with methods. For example, I have empty stack and I want to push box A. So it's going to be stack of boxes. And that's what I have after push. Again, push is insert or add element to the stack. Now I want to push box B, and that's what I get. You can see here, I even don't see the bottom element here. I don't know what it is. I don't. What I can do, I just can see the top element. Let's say I want to push box C, and that's how my stack looks like after pushing C. Let's say I want to pick at the top element, so it just returns top element, which is C in this case. Then I want to push box D, and that's how my stack looks like. And if I want to pop stack, it just removes D, and after pop in the stack. That's how my stack looks like. And just note, here I specify what I want to push. Push box A, push box B, C. So they are your parameters. Box A, box B, box C. And you can see here for peek and pop, I do not have any parameters. I do not specify anything. Why? It's simple because I have only one option on the top element. I cannot say I want to peek at some specific element. No, it's always top. The same with pop. I cannot remove any specific element. I can remove just top. Here's some examples of the stack which you see all the time, like every day probably. For example, web browsers store the addresses of recently visited sites on a stack. Each time you visit a new site, it's pushed on the stack. Browsers allow to pop back to previously visited site. And we see it every day if you use internet. And of course, the undo mechanism in an editor, for example, in Word or any other editor application. For example, when you write some document, the changes are kept in a stack. When the user presses undo, the stack of changes is popped. And of course, Java methods or method calls. And we already know this from Java 1. So you familiar with method calls, right? So it's also they are also kept on the stack until it's complete. The method is complete. So how do we implement stacks? Stacks can be implemented efficiently with both arrays and linked list. And we already know linked list, and of course we know arrays. So here you can see array implementation of stack. Just a regular array with some restrictions. And that's how you need to think about stack when you code stack. It's just think about it, just a regular array which has some restrictions. Which restrictions? You can access only top element. You can remove only top element. In this case, it's the last one. You can add only to the end of the array, to the last position of the array. So, and here you can see linked list implementation of stack. A linked list provides fast inserts and deletes at head. You just need to keep top of stack at front. You can see it here. We will see more examples. So the array implementing a stack is an array of references variables. Each element of the stack can be assigned to an array slot. Let's first talk about array implementation. The array implementing a stack is an array of reference variables. Each element of the stack can be assigned to an array slot. The top of the stack is the index of the last element added to the stack. To keep track of the top position, declare a variable called stack top. So we always need to keep track of the top. And here you can see some example. It's your array. and you have stack elements, which is A, B, C, D. You need to be able to work with stacks, you need to define, to assign some size to this array. And of course, you need to keep track of the top, and top is here, which is position 3. And yeah, and it's your array. Of course, you need default constructor for the stack, and just like I told you before, we need to define size of the array. We need to initialize top, and of course we need to create an array. I will show you how to code it. Of course, you will have to check if it's empty, if it's full, method to push, method to pick, pop, and just let's code it together. Let's see how stack works. We are going to write a program and create stack, add some elements to the stack, and perform some operations like push, pick, and pop. So I start with creating a class, public class, my stack. I'm going to name it my stack A. A stands for arrays, because later on we will see how linked list works. But now it's just for arrays implementation. So I'm going to create my stack, which is stack of strings. But basically you can see it's just array of strings. We have seen it before, right? So it's array to hold stack elements. And now I'm going to create top, which is pointer to the top element of the stack. Now I need my default constructor, just public and name of your class, which is my stack A. And here where I actually create my array or my stack. New string. Let's say it's going to be size of 10. And my top is 0. I initialize my top with 0. That's it for constructor. Now let's check if it's empty or not. Is empty method checks for an empty stack and returns true if a stack is empty. So let's write this method. Public boolean. Why boolean? Because we return true or false. False otherwise. and name of the method is empty. How do we check? We return top equals 0. So what it means? If top is 0, stack is empty, and it will return false otherwise. So let's write a tester to check if my stack is empty or not. So public class my stack tester, I will name it like this, and it will contain a main method, public static void main. So now I'm going to create my stack or instance from my class, my stack A. That's how I name it, right? My stack A, yes. Equals new my stack A. We know how to create an object, right? Object. So now I'm going to call my isEmpty method here to test system out println let's say is empty. Yes. So name of your stack, which is here, name of your object, right, is empty, and then you call the method. So let's compile it, run, and we see it's true. Now let's write a method to push elements to the stack. Public, so yeah. Let me put some comments here because I'm going to upload this to the website or to the Blackboard probably. So the push method pushes a value onto the top of the stack. Remember, there are no options, it's only top. And we will have one parameter. Why do we need parameter here? Because you want to add something, you want to push something, and we need to tell the program what exactly you want to push. That's why you need parameter, right? And your parameter will be the value to push onto the stack. it's not going to return anything. I just want to push and that's it. If you want to add and then return true or false, it was successful or not, you can do this. But I'm going to show you just how to push it. So it's going to be void. We are not going to return anything. And method name is push. And of course we need a parameter. A parameter is going to be string. Why string? Because my stack is 4 strings, right? Stack of strings. So now it's very important to understand. So basically how we add new element. Just pay attention. It's how we add new element to the stack. How we push it. It's the same how we push, how we add any element to the array. And it's very easy. So it's name of your stack, which is stack, right? It's here. Since it's arrays, you need to specify position. And I specify, and our position is top. We don't have any other options. It's just top and that's it. So for example, if our stack is empty, it will go to the stack at position 0. Or you can think it as array. So it will go to the array at position 0. If it's empty, right? Like this. But if it's not empty, it's not, somehow we need to change our top, right? We need to keep track of this, because what if you're going to add second element? Of course, that's why we need to update our top. So it's just top plus plus, right? So it looks very simple, and it is, but we need to add here something else. So just first add a new element and update top. So here we are missing something. There is a problem. You remember we work with arrays, and sometimes it can be full. I mean, the capacity of the array can be full, and we will get an error, and we don't want any error. We don't want to crash our program to be crashed. So that's why we need to check for the length. So how do we check? If top equals stack.length. So basically what it means, if our stack is full, if stack is full, we would need to throw some exception here. And just say, you know what? We cannot accept any more elements to the stack because we are full. But that's what we really want. I mean, yes, your program will not crash, but at the same time, we can increase capacity of our array. And actually that's what exactly we want to do here. So before we finish this method, let's write another method to increase size of our array, of our stack. because you can throw an exception, but it's not going to solve any problem. What if you still need to to add more elements to your stack? It's not going to solve the problem. That's why instead of exception, here we will increase capacity of the stack. So how we can increase capacity? I will write another method. I will name it the ensure capacity method increases stack capacity, let's say by 2 times. Of course, you can increase more if you want to. I will just double it. And I will make this method private because I don't want to use it anywhere, but I want to use this method just inside my push method, and that's it. That's why it's going to be private. So it's private void ensure capacity. And inside this method, what I'm going to do, I'm going to create new stack, with size of stack that length times 2. That's what I want to be my new stack. 2 times bigger or 2 times longer than my old stack. That's why the new size is stack.length multiplied by 2. So I created new stack, and I'm going to have a for loop where I will copy old stack to the new stack. All values of the old stack to the new stack, because I want to keep them, right? So just regular for loop. So new stack at position I. That's how we copy, right? So it means that each element of the old stack goes to the new each element of the new stack. So copy each element from the old stack to the new stack. And it's also very simple. It's just from also Java 1. And of course, you need to do this. So in our push method, what I'm going to do in case my stack is full, I'm just going to call this ensure capacity method. So if it's full, our stack will be increased by 2, and then we still will be able to add new elements to the stack, right? So let's see how it works. Let's test it. I'm going to my tester class. So what can I do? How do I actually populate or push my elements? So it's name of your stack, which is S, and just you call the method push. That's what you want to do, right? And let's say I push EPCC string. Probably I will push something else like Java. No, let's first just push EPCC. And then I'm going to call is empty method again to check if it's full or not. Oh, if it's, if it's empty or not. Compile, run, is empty true, then adding EPCC is empty false. So now let's write another method. Let's do pick method. Pick method returns value of top element of your stack. So the pick method returns top element of the stack. We don't have any parameters here. Oops. Why we don't have parameters? Because we don't have any options. It's just top and that's it. So we have nothing to specify for, we have nothing to ask for. So it just returns value of the top element. Of the stack. Okay, so far I will leave it like this. So now, yeah, just let's do it. So it's going to be public and return type is going to be string. Why it's string? Because we work with the strings and our stack contains strings, right? And I want to return value. That's what it means. I'm going to return string. And name pick, no parameters. And now it's very easy again. So just think about it as a regular array. First of all, I'm going to create a string which I'm going to return because I need to return it, right? Okay, it's going to be name of our stack, which is stack. And what is, just think, if you look at the array and think what is last element of the array. And we know, right? It's top minus 1. Because each time we push something, we update our top. And top is last element of the array. But since arrays starts at 0, we need to do -1. because we want position and not number, right? Not length, but position. That's why -1. And of course, after we did this, after we pick, we just need to return it. Return R. So basically, top element of the stack. So basically what you could do, you can just return stack at position top -1, right? So just again, think about this as an array. You just need to return, for pick, you just need to return stack at the last position. Last position is top -1. We almost done with this method, but not really. So if your array is empty, oh sorry, I shouldn't say this. If your stack is empty, it's going to crash. And we don't want our program to crash, so that's why we need to handle this exception. So first thing to do is to check if it's empty. And of course, we cannot return something what doesn't exist. We cannot access something what doesn't exist. That's why it's going to crash, right? So we need to check if it's empty. And if it is empty, if it's true, we need to throw new empty stack exception. And just saying stack is empty. So you can ask me right now, of course, remember we need to throw exception as a method header. So why do we need, we just need to tell our main method that it can be happen, so we need to always to specify it. Now it's like perfect timing to ask me, like, where did you get this exception? Is it built in? Is it provided by Java? No, it's not. That's why we need to create our own exception. And you already learned how to do it several weeks ago. So I'm just going to create a class for exception. Public class empty stack exception, and I'm going to extend exception class of Java, right? And public empty stack exception. This is my constructor. String s. I'm just going to call superclass of exception class with parameter string, and that's it. We already have done it before. It's always the same, right? Yeah. So we are done with pick method. And again, we created a pick method that returns top element of the stack. Public string because we want to return a value of the top element. And pick is name of the method, and it throws empty stack exception. So if is empty, if stack is empty, how do we check if it's empty? We already wrote this method is empty, right? And I'm just going to use it whenever I want to use it, like in this case. So if it's empty, it means I don't want my program to crash. That's why I'm going to draw new empty stack exception, which I just defined here in separate class. And in case it's empty, I just print stack is empty. And actually how we pick, I created a string R and value of the top will be at position top -1, and I just return it. So let's check this method. Let's say I want to pick before I add anything. I add here some stuff, but I want to pick before I push. So that's why I want to show you the error. So system out println what is the top plus pick as pick. So now if I compile, I get an error and it's saying unhandled exception type empty stack exception. So this happens because we never use try and catch statement. I'm going to try everything here, and then I'm going to catch it with empty stack exception, and name of the exception E, and I'm just going to print whatever my method prints. System out println E. Now let's try it again. Compile, run, and you can see is empty, true, empty stack exception, stack is empty. So this is what we get because we call this method before, where's this method? This method before we push anything. So now when I pushed EPCC string to my stack, I want to pick. Compile, run, let me just comment out everything. Compile, run, and what is the top? EPCC. So now let's say I want to push something else. And this something else, let's do Java. So adding Java. And now I want to see what's my top. Compile, run, and add in the EPCC, add in Java. What is top? Java. Let's say I want to add something else. Let's do CS and add in CS, compile, compile, run, and we can see what is the top, CS. So whatever I pushed the last, that's my top, that's my last element. And I cannot access anything else, just last element, just the top. And let's write the last method to pop, which will remove top element of the stack. So the pop method pops the value of the stack, and it returns value popped, and of course this is top, and of course this is top. Remember, we push and then we pop only top. We cannot, just like with a pick, we cannot remove or we cannot pick anything but top, and the same, we cannot remove anything but top. Now let me add here something else. Throws. Empty stack exception when the stack is empty. And here for the pop method we need also to throw the same exception. Yeah, we need this because it's going to crash for the same reason. When you try to remove something which doesn't exist, it's going to crash. So public static, public string, because we want to remove string, and we want not just remove string, we want to return string, just like we did for pick method. We want to see what actually we removed. So string pop, no parameters because there are no options for us, we just use top and that's it. Throws empty stack exception. So those methods are very similar. I also need to check if it's empty, and if it's empty I'm going to throw new empty stack exception, and I'm going to say you are trying to remove something that does not exist. It's my message, right? Okay, and now how we actually remove it? Okay, first I want to return top, and we already know how to do it. It's going to be exactly like this. I'm going to create string because I want to return it. So let's see. It's stack at position top -1. But this time I'm not just picking. I actually need to remove. How do I remove? It's very easy. You remember how you remove from the array. It's kind of the same last position of the array. It's just top -. So we're just updating our top. So our last element will be top -1. That's why. So we just need to decrement the stack pointer. And that's it. Of course, we need to return R, which is our value of the top. Of course, sometimes if you want just to remove and not to return anything, you can use just void, for example. It means then you don't need this line of the code, you just do top -. But it's better to see what actually you remove, right? Just let's test this method very quick. So I picked here, I will comment it out. So how do we remove? System out print line and removing top. Name, pub, no parameters, run, removing top, CS. So let's make sure we actually removed this. Now I'm going to call method pick to see what my top now is. Compile, run, removing top, CS. What is top? Java. Because we removed this guy and now our top is Java. So if I'm going to remove something else, compile, run, removing top, Java. And now if I pick again, what do I expect? Compile, run, and what is top? EPCC. Of course, I can remove that too. I'm just going to call pub method again to see. Removing the top, EPCC. And now, if I pick, what do I expect? I expect stack is empty. Or let's say I want to remove something again, run, and saying you're trying to remove something that does not exist. And it was a lecture on stack array implementation, and again, just it's nothing complicated. It maybe for you it might looking just scary a little bit, but just think about this and as an array, just regular array with some restrictions. And restrictions are you push only to the end of the stack and to the last element of the stack, to the last position. And you pick and pop on the top, which is the last element of the stack. And in last lecture, we are going to talk about stack with linked list implementation.